Howdy guys, on this lesson on merge and quicksort. So let's start with merge sort. Um, Merge sort is a divide and conquer algorithm. This means you're going to divide your huge problem into smaller, tiny little itsy bitsies pieces until you can actually solve it in an easier manner. So in this case, in merge sort, we split our entire array in half, and then we split that array in half, and then we split that array in half, and we see that exact same situation playing out here. 7, 3, 2, 16 to split, all until you reach a base case where you've split it into items of 1. At that point, what you're going to do is you're going to start combining them. And when you combine these two, you're going to want to merge it, hence the name, and you're going to merge it into a sorted order. So here we merge 3 and 7, we switch the order. Eventually, when you order these, you're going to merge them again, so on and so forth. For all cases, you're going to have a time complexity of O(n) log of n. This is the recursive equation. You should definitely know this for the test. This one along with the time complexity. It is not an in-place algorithm. I'll repeat this. This is not an in-place algorithm, but it is a comparison-based algorithm. So yeah, you should probably know these bottom 4 bullet points pretty well. Quicksort is an extension of this, of merge sort, but instead of always splitting it right in half, we're going to choose a pivot. So let's say our pivot's going to be this last number. We're going to split our list into 2. And how we're going to split this list is everything less than the pivot, so in this case it's 3, goes on the left side, and everything greater than pivot goes to the right side. And we're going to pick our pivot again, always, like in this case, when we choose our pivot, we're going to choose our pivot to be like the furthest right number. And we're just going to stick with that rule, right? So we picked 3 here, we picked 1 here, we picked 6 here, all the furthest right number. And then again, we keep doing that. And at the very end, we're going to do the exact same thing as we did in merge sort and start combining them into a sorted order. Now let's think about best, worst, and average case. You should know these 3 cases pretty well. In what situation they occur, what's the time complexity, and the recursive equation. So in the best case, the pivotal value is going to be the median. If it's the median, you're going to split these 2 lists into pretty even chunks. And that's the best thing you want, right? You want that your 2 problems that you create to be split up evenly. In the worst case, your pivot value is going to be either the max or min. So let's say in this case, we pick the pivot value of 9. When we put left into right, you notice the entire list except 9 is going to go to the left, and there's going to be nothing on the right. And let's say we pick the biggest one again, so down here would be 8. Again, the entire list except -1 is going to be on the left, and then there's going to be just 1 on the right. So this is no better than O of n squared, because each time you're just subtracting the size of your array by 1 as you go down in depth by 1 level. On average, you're just gonna like pick between like the best and the worst case. Like it's not the median, but it's not the max and min. That's kind of the average. So you're gonna get a big O of O(n) log of n. And this is the recursive equation you get, which is t n divided by 9 plus t 9n divided by 10 plus O of n. Again, this is an in-place algorithm, and it's also comparison-based. So thank you for coming, and have a great day.